This video discusses our angular momentum kit. This kit was designed specifically to address a high school standard on qualitatively measuring angular momentum. To do that, we are going to build a rotational device in which you can move different masses along the meter stick and then measure the speed it takes when it rotates around. This allows you to calculate the change that happens when you adjust the distance from the axis of rotation of the mass, and that will allow you to then look at torque, rotational energy. You can also use this to look at Newton's 3 laws of motions. Let's get started assembling it. Take the pencil piece and slide it into the T-rail on the ballista base frame. If you're noticing a little bit of friction, slide it back and forth to remove any excess overhang material that might have drooped a little bit during printing. Then take the first rubber band and loop it around the front of the ballista kit. Take the hook and slide it onto the little cylinder at the back. Then take another rubber band and slide it into the notch in the hook so that it is holding the hook down. Then loop the final rubber band around twice and go over both of these little peg pieces at the front. To finish assembly, take your number 2 pencil and slide it into the pencil piece. And now you have a force generator mechanism that will release this pressure in an equal way every time. To reset it, slide the pencil piece back, push on the back of the hook, and then let it latch on that little peg at the back of the pencil piece so that it holds it ready to go. And then to release, simply push down on the back of the hook. To assemble the rest of the angular momentum kit, we're going to start by placing the 3 pencils into this top piece here, attach the bottoms of them into the pencil triangle base. Next, take the ball bearing and set it on top. You can then use the top piece here and slide it in. So now you have a rotating piece that uses the skateboard ball bearing for a low friction rotational system. And then take your meter stick and slide it until it is centered and well balanced. Once it's ready, you are ready to add your masses. We provide 2 different masses. We provide one that's close to 5 grams and one that's close to 10 grams. That way you can do different activities where you say, measure with 5 grams out here, then here, compare with 10 grams at each of those same locations, or all 15 grams combined for those 3 locations as well. And then you get a chance to graph and analyze the data to see the change in rotational speed at these different locations of the mass. So choose which mass you'd like to do and set it up at your first location. You want to make sure it stays balanced, and you'll use a small binder clip on the outside of your weight to make sure that it stays in place. You can then see that it rotates freely around with the masses on it. And then you're going to want to use the force generator mechanism to push the object, or to push the outside of the meter stick. That way you're getting a consistent force with each of your trials. You can then calculate rotations per minute and compare at this distance of the weights to when they've moved closer into the center. So this connects with ratios and proportions as you are doing rotations per minute or per second. You can calculate that. You can also integrate with your math classroom by talking about the circumference of the circle you're making versus the diameter that each of the weights are at their 3 different locations. So in addition to addressing this higher level physics standard, you get a chance to also talk about some different math concepts as you do so. Be sure that you are releasing your launch mechanism from exactly the same location every time, which would be the outside of the meter stick. So there you are. That's how you assemble and use the angular momentum kit in your classroom to discuss a lot of interesting things regarding angular momentum, rotational energy, and torque. We hope you enjoy using this and getting into some really interesting analysis in your high school physics class. Thanks for listening.